this video, I'll demonstrate how to use the Securosys XKS Proxy with AWS Key Management Service backed by a Securosys hardware security module. With this setup, AWS does not hold your key material. The key resides in your own Securosys HSM. But what's the point? Key sovereignty means your keys stay under your control, so only you can use them, helping you meet compliance requirements and stay in charge of who accesses your data. A common and simple demonstration for this integration is server-side encryption for an S3 bucket. When you upload an object, S3 will call AWS's KMS, which in turn calls the XKS proxy, which calls your HSM to encrypt each object in the bucket. And of course, when you download an object, your key in your HSM is used to decrypt. Later in this video, I'll demonstrate that workflow end to end. Before we dive into this demo, let's quickly cover what needs to be in place for the integration to work. Keep in mind you have flexibility in where you deploy the Securosys XKS Proxy, starting with an AWS cloud-hosted EC2 instance like what I'm using for this video. This keeps it close to AWS services and is quick to stand up. Next, you can run it in your own on-premise data center, which gives you full control over the infrastructure. You can also deploy it in a private cloud environment, aligning with your internal hosting and security requirements. And finally, it can run as a containerized deployment using Docker or Kubernetes, making it easy to integrate into modern application platforms. Regardless of where the proxy runs, the HSM remains the control point for key usage. I won't deep dive into the AWS setup, that would make this video a bit too long, but let's do a quick review of how I have my AWS environment configured. You'll of course need a VPC, and within my VPC, I've got my EC2 instance where I'm running Docker for the XKS proxy. I've got my network load balancer with my EC2 instance in the target group, and I'm using a VPC endpoint service for private link routing rather than my KMS calling the XKS proxy over the public internet. Now, to provide a stable endpoint for KMS encrypt decrypt calls, you'll need a host name with a valid TLS certificate. This enables private DNS mapping via my VPC endpoint service, or aka the private link. Think of it this way, KMS connects using an HTTPS URI. That URI must resolve to your VPC endpoint service and match the certificate presented by the network load balancer. And finally, the fun part, in the KMS service, I have my external key store created and connected, which is where we'll create our keys. The final part of this video, I'll show you what happens when we disconnect the proxy and can no longer access encrypted data inside this S3 bucket. Why? Because it can't reach the Securosys HSM for decryption, which is really the whole point. Okay, here's my EC2 Linux host in AWS. A couple tools you'll need to make sure are installed in your EC2 instance are Docker and KeyTool. Docker provides the container runtime that the XKS proxy uses to launch and manage the application. I'll show you what I mean when we configure the proxy in a minute. And you need KeyTool to create the Java key store file that the XKS proxy uses for HTTPS. Let's start with creating the Java key store file. In this step, we generate the TLS certificate in Java key store format. The XKS proxy is a Java application, so it requires a JKS file. I have all commands pre-staged, and I'm going to speed this part up and skip straight to the final verification step, showing you my JKS file. You can pause or slow down to copy this process. One final verification, and there's our TLS certificate in Java key store format. The cryptographic root of trust in this architecture is, of course, the Securosys Primus HSM, either on-prem or in the Securosys cloud. The XKS proxy communicates directly with the HSM to perform cryptographic operations, while key material never leaves the HSM. In this video, we won't walk through the initial HSM setup, but you can find instructions for that on docs.securosys.com. For the purpose of this video, my HSM is already initialized and reachable over the network from the EC2 instance where the XKS proxy will run. A simple test to ensure my EC2 instance can communicate with my HSM is to telnet to the HSM IP on port 2400. This IP and port may differ depending on which Securosys HSM service you are using, But again, you can obtain this information from our docs website. Just look for HSM connectivity details. At this point, our environment is ready for the Securosys XKS Proxy, which we can download directly from the Securosys support portal. Or if you're familiar with JFrog, this will look pretty standard. The XKS Proxy container is hosted in the Securosys JFrog repository, and you simply pull that image when deploying the proxy like this. Okay, let's get the proxy YAML configured before we upload it. This part is really easy, but I hope you wrote down a couple of the things from the JKS certificate generation step. Here's our YAML on the left. I have the commands pre-staged. For security purposes, I'm not displaying user and password parameters, but you should have obtained your HSM credentials from the HSM initialization phase, and you should have the key store access key ID and secret access key when you created the key store in AWS. And finally, under DNS, you'll want to enter your Java key store password and key alias you created in the certificate generation step. Okay, I won't make you watch me paste everything in, but if you need a good reference, take a look at this handy chart under the XKS integration instructions on docs.securosys.com. Here we are at my local host. Installation of the YAML file is simple. We just need to deploy the XKS proxy as a Docker container from our EC2 instance. I'll SCP the YAML file from my local host to my EC2 instance, and done. And back to EC2. Now, because the XKS proxy reads its configuration from the opt Securosys XKS config directory, we need to create that directory, and while I'm at it, I'll lock down the proxy settings to root so we don't get any feedback from our EC2 instance. Follow these commands for this part with a couple of quick verifications. Okay, let's start the container running the proxy and verify that it's up. I want to make sure it's listening on port 443. This part can take a second. And I like to make sure it's logged into my HSM. And there it is, successfully logged into the Primus HSM. Now let's move to a real-world and practical use case by creating an XKS-backed key for a server-side encryption of an S3 bucket. First, we need to create the key. Here's my key store. I'll click here to create a key. I'll give it a name of S3 key 1. Let's give it an alias. I'll quickly set my permissions. And click finish. And there's our key. Now let's make sure my S3 bucket is using my new key. Click on Properties under your bucket and scroll down to Default Encryption. Note the ARN. Click Choose from your AWS KMS keys and find the key we want to use under Available AWS keys. There's my key, and click Save Changes. Okay, let's add some data to that bucket. I'll create a simple text file with some text in there, and I'll save it as encryptme.txt. Now I'll upload this text file to my S3 bucket, and there we go. Quick check from the EC2 to see my file contents using this command, and there's my data. Taking a peek at the Docker logs, we can see that simple check was made possible by my private key stored inside my HSM. We see the decrypt request from an external key called S3 key 1. Now let's stop the XKS proxy and see what happens. Before we do that, there's our data decrypted by our key. The proxy is running. Let's stop the container. Container is not running. Let's try to view our file now. And we can't as expected. Let's restart it and verify it's up. I want to see in the logs that the proxy has logged into the Securosys HSM. This takes a second. And there it is. And now our key can decrypt that file again. As a last check, let's do the same thing, but try to view that text file in my S3 bucket from the AWS console. The proxy is running. Let's stop it. Nothing running. And let's see if I can view my file or download it. And we can't, as expected. Can't download either. I'll restart the proxy. It's logged into the HSM and back on the console. Now I can view my data and download it. Now up to this point, I've shown that if I stop the XKS proxy running in AWS, key operations stop. But from a sovereignty perspective, that control still technically lives inside AWS. So let's move the control point to the HSM side. First, I'll show that the XKS proxy container is up and running. Next, I've got my HSM console here. I'll disable the JCE API, and that cuts off the cryptographic interface as the source outside of AWS. Let's tail the proxy log so we can see the health status go from active to giving us an error of user interface disabled. Okay, back to my S3 bucket, and I'll try to open our text file, and of course, it can't be decrypted. And there you have it. You've seen AWS services encrypt and decrypt using a key that you own and control in your Securosys HSM. Keys never leave the HSM, so control stays with you. You can stop key usage instantly at the HSM, independent of AWS, giving you a clear separation between cloud operations and key control. This integration supports strict compliance and data residency requirements and gives you full auditability of key usage and access. And that's the essence of Securosys XKS Proxy, cloud convenience with real key sovereignty where you decide where the keys live and how they're protected.